Don't you remember doing that?
It's not bad enough. I need your help with it too. Thanks.
Gaslights are us.
Friends like you.
Gaslight are.
Actually, you should change my address up there to gmail.com. It'll be more consistent and it actually works.
Okay.
People are gonna wonder why you.
It was open line, so I won't stop them.
Okay, so you want, is it David.Cinicro?
It's the same, yeah.
Okay.
It's David.Cinicro@gmail.com.
And this is saving it in the Dropbox. So that's perfect.
Start, shouldn't we really?
Yeah. Yeah, we have to go through the beginning slides anyway. Hello, everybody. We are live. Okay. I'm Andy Malice. This is Stuart Bryant, and we are in PALS in Bangkok. And thank you all for coming. This is the Note Well, which I'm sure you all know well by now. So we have one item on the agenda, and that's going to be draft UC PALS PW CW stitching from Attila Busey, who was in the room a minute ago, and we expect him back pretty shortly. Since we last met, we actually did not meet at IETF 102. So since IETF 101, which is the last time we met, we've had one new RFC, 8339, which was PALS P to MP PW LSP ping. And we've now had 18 RFCs published for PALS since it was reformulated in November 2015. So we have been a pretty productive working group. We have one item in the RFC editors queue, draft IETF PALS Ethernet CW07. The current status is that it's an auth 48, and we just got the last sign off from the authors this morning. So we should expect to see it pop out from the RFC editor into an RFC pretty soon.
You should already have the RFC number.
Yes, yes, we do already have the RFC number, but we are sworn to secrecy until it's published.
It makes the control word.
It makes the control word
Recommended.
highly recommended, but not mandatory. Yes. Okay, and right now we have no other working group drafts. However, we do expect that to change soon. And that's it. Any questions before we get started with the Attala's draft? Seeing none, let me switch over to Attala's draft.
Dave will be chairing discussion on this.
Yeah. So given that all the chairs are authors, I'm going to chair this. Just make sure that there's a flavor of transparency here.
There's a big controversy going on.
There's a big what? Controversy? Yeah, I started looking at the draft. It's like, wait a minute.
There's a lack of transparency in
Yeah.
that.
Oh.
Yeah.
What I did?
It was much better in this one.
Yes.
Going the other direction.
Okay, go ahead. Tell
Okay, got it. Okay. Yes, it's working.
Yeah, very good.
Okay, thank you. Okay, this is the presentation. It's discussing about stitching pseudo-wire with different control word capabilities. So what is the problem statement? The problem statement that we have is that we want to be able to send packets, pseudo-wire packets, use the control word, also in a situation where at least one of the TP in the network is not capable to insert the control word. And this is in an existing deployed network where we have this box is already in the network and it's sending traffic to another TPE. And even if TPE1 is not able to send a control word, we want to be able to make sure that the packet that goes through the network gets the control word. This is motivated by the draft that has been recently approved, which is recommended to use a control word, but it's not possible to insert a control word if TP1 cannot do that. And one option that was discussed at the time when we developed the draft was replacing the old piece of equipment, which is a possible solution. People can do that, but it's not always viable. Sometimes there are operational or economical reasons why the operator don't want to replace a piece of equipment which is already installed in the network. And we don't preclude this option, but we want to provide an alternative option that can be used in case the operator doesn't want to replace the old piece of equipment, but still protect the traffic through the network. So what is the idea? The proposal is to have a new type of node, which is a sort of switching PE, which is capable to switch an Ethernet pseudo-wire segment set up without the control word, and an Ethernet pseudo-wire segment which is set up with a control word. And if we deploy this SPE very close to TPE, we can easily control the ECMP behavior between TPE1 and SPE1. If, for example, is a link, is a collocated link, or is a small size network, so we can make sure that there is no ECMP here. So this traffic is not affected by the lack of control word. And then before sending the traffic through the network, the control word is inserted by the SPE. So that's the idea, is to set up a multi-segment pseudo-wire in this way, and this solution has minimum or no service disruption, because you can install this new box or upgrade an existing box with this new capability, set up a new multi-segment pseudo-wire through this SPE, and then you can take the traffic. You can use, for example, pseudo-wire redundancy to move the traffic from the old pseudo-wire, which was going through the network without a control word, to the new pseudo-wire, and then delete the old pseudo-wire. So this could be done with the minimum interruption of the service. And the assumptions we made in the draft is that the capabilities of TP1 are the same, no matter whether it is terminating a single segment pseudo-wire or a multi-segment pseudo-wire, which are consistent with the RFC 6073 assumptions about what the TP can do. So this draft gets more in details about how it works from a data plane perspective. So the TP1 generates packets without the control word. So we have the Ethernet frames with the LSP label and the pseudo-wire label. And then when SP forwards the traffic based on the pseudo-wire label, in addition to swap the pseudo-wire label and decrement the TTL, is also inserting the control word in between the pseudo-wire, the bottom of the stack, and the Ethernet frame. So there is a change in the way the SP forwards the packet, but the way TP1 and TP2 sends and receive the pseudo-wire packet are exactly the same as of today. So there is no impact. All the impact on the data plane are on SP1. There is no impact on existing devices in TP1 or in the P nodes. No upgrades is needed on the data plane on the other nodes. And then when we do this change of the forwarding plane of the data packets, we have an impact also on the way the SP1 can forward VCCV packets. And we have made some assumption in the draft to make things more easier, because otherwise we get too many combinations to deal with. So we assume that on the segment where we have the control word, we always use a CC type number 1, which is the default and mandatory mode in the VCCV RFC. So we can assume that if TP2 supports VCCV, it should support CC type 1. So what we need to do, we need to translate between different CC types that can be supported by TP1 into CC type number 1. And in a draft, we describe a translation for CC type 4 and translation for CC type 3. Do you have a question, Matthew?
Yeah, I just got a question about actually the previous slide.
Yep.
Are you doing a label swap and then inserting a control word
in
an already labeled packet?
Yeah.
That's not in pseudo-wire architecture to be able to do stuff like that. I don't know if there's any chips that can do that. That looks more like the old pop and push of TMPLS.
You've got to rebuild the stack, haven't you?
Yeah, you got to. So it's a pop and a push. Really, it's two pseudo-wires being stitched together, not
Yeah.
one pseudo-wire end to end.
Yes. So the question is, do we need to formally update the architecture? I suppose we should at least say we're updating it.
Well, for this one
Yeah.
very kind of corner case,
Yeah, indeed.
why can't you just stitch? I mean, we've already got native service stitching in the architecture, and that's pretty much what this is, because you've got two. You're basically breaking it down to the Ethernet frame somewhere. You're popping the label coming in.
Yes.
You're coming up with an Ethernet frame, and then you're pushing a label you're pushing a control word and a label,
Right.
which is exactly that. And there's lots of boxes can do that kind of thing today. We just do an internal sort of cross connect on the native service, and you're done.
Yeah, so it is, you're right, it's a native service.
Yeah, which is already in the architecture. So I don't think we need to do that.
Change the draft.
If you just, I think changing the draft to point to that example
Okay.
in the architecture, so this is all you're actually doing.
Yeah.
So basically, this is not a switching, it's not a label swap.
No, technically it's not.
It's a
right.
forwarding container where there are two pseudo wires, one with the control word, one without the control word. And it's
Yeah.
just moving the traffic from,
Yeah.
from one to another.
Although you might do end-to-end, well, you might do end-to-end OAM.
Yeah.
Well, that's kind of my
Yes,
question. Is really the point of this? Only
Yes.
to get
You
into.
cannot do end-to-end.
Yeah, but you can, because you can do Ethernet OEM on the Ethernet layer with CCM on that, so you haven't lost any kind of end-to-end.
Well, you can also do it with the TTL version.
No, because you're terminating the pseudo wire on
Yes.
The pseudo wire ping, trace route.
Gets immunity, yeah.
DFD, everything terminates.
So that's the idea here is not to terminate, you don't need to know the packet, the payload, you just have to insert the control word as part of your forwarding.
But why don't you
Yeah.
just do CCM on the Ethernet layer? Between TP1 and TP2, you can just put MEPS on TP1 and TP2.
Yeah, you cannot do VCCV end-to-end then.
Right.
Yeah.
That's not native.
Yeah.
It's true. It's not VCCV, but
Yeah.
you're kind of because you're popping pseudo wire over anyway.
TTL, though, can't you? What you could do, you used to be able to do VCCV on a pseudo wire without control word anyway, can't you?
But you lose. Well,
We can do this without control.
yeah, but not strictly because you're popping that pseudo wire label rather than swapping
Well,
it.
yes, so there's a question of which is the worst of the two evils, describing it one way or the other.
Well, I think describing it as a swap is just not a.
It's not a swap, you're right.
It's not a swap, yeah, it's,
But once you say it is not a swap, that means that pseudo wire is terminated. The ping, trace routes, everything terminates that.
Right.
It is not end-to-end anymore. The difference here is that since it's a switching PE, the pseudo wire is end-to-end. It's just that intermediate in between and the switching PE are inserting the control word.
Yes, the payload is really the only thing that's end to end.
Yeah.
So like you said, basically everything is terminated and you start it over again. So it actually looks more like a TPP in that case.
So
right?
I think we should sort of go up a level, which is to say, is this a useful function? If it's a useful function, then the rest of we'll figure out how to make it work and then how to describe it. So that's really the key question, because if it's not a useful function, then we should stop it.
Yeah. It's just kind of, to me, it's just kind of describing a use case of that native service stitching.
Yeah.
Being a co-author, what are your thoughts on that?
I was just presented with an interesting technical problem.
Yeah.
But,
yes, I think we have to think about the end-to-end VCCV and the redundancy as well, because one issue is that we need to move the traffic away.
So,
So how do you,
right. So, I mean, I
Sure.
would continue go on under the premise that, let's figure out if people think this is a useful
yes,
function.
yes, exactly, yes.
right? And then we'll figure out how to solve
How
the
to
problem.
describe, it's okay, yeah. So, okay, and, as I said, you can have CC type 4 or 3, and here you assume only 1. In the draft we describe both 3 and 4, but in the slides I presented only the 3 because it's the most complex one. So what you get here is also another strange, more complex operations. So what you get, you swap the label, you decrement the TTL, and then you have to insert the ACH between the pseudowire label and the IP header. And the channel type will be set based on the IP header version field. And you do the same in the opposite direction. And the assumption here is that the SPE should know the TTL distance to the TPEs, because the TTL is the discriminating factor that tells the SPE whether the packets being forwarded is an OIM packet or is a data plane packet. So the different operations should be based on the TPE value of the pseudowire label stack. Okay, then it's in this slide we analyze that, and again, no impact on TP1 and TP2. So the VVCV packets generated and processed by TP1 and TP2 are exactly the same as today. So only SP1 needs to be updated. And the signaling procedures is also the same. We need to upgrade a little bit the protocol rules to be implemented by SP1. So SP1 should always behave as if toward the pseudowire segment, as if the other pseudowire segments has signaling control word support. So if TP1 signals to SP1 no control word, but since SP1 can translate the control word, it can still negotiate C equal to 1 toward TP2. But of course, toward TP1, it will negotiate C equal to 0 because TP1 does not support the control word. And it can be done, and then it does with label withdrawal or not, depending on the sequence of actions, because it depends. Sometimes it can start with C equal to 1, and then if C receives the C equal to 0 and then withdrawn, or it can start from C equal to 0, depends on between this message, which one comes first. But the behavior is exactly the same as in the current RFCs. The only difference is that no matter what the C bit you receive from the other pseudowire segment, you always try to negotiate the C equal to 1, because you can insert the control word. And the same applies to the VCCV. So what the rules are a little bit different. So the behavior from the protocol perspective, TP1 and TP2 cannot say the difference, but the rules inside the box are slightly different. So in this case, what happens is that SP1 advertises to TP2 CC type 1 if and only if it is receiving from TP1 a CC type that it can translate into TP1, into CC type 1. And in the reverse direction, it is looking at CC type 1, because we are assuming here to use only CC type 1. If TP2 notifies support of CC type 1 to SP1, then SP1 can notify TP1 supports of all the CC types it can translate. And in this slide, we are assuming that SP1 can translate between both 3 and 4. So SP1 can notify TP1 both 3 and 4. But if TP1 supports only 2 and 3, then only CC type 3 will be used in this segment and CC type 1 in this segment. So these are the rules. And the last rule is because if TP1 supports 3 and 4, but SP1 cannot translate CC type 4, then we want to make sure that ACH-based CB types are not negotiated. So SP1 will not propagate support of, will not notify support of ACH type, which is IP-less BFD, for example, unless it's able to translate between CC type 4 and CC type 1, because without control word, only CC type 4 supports the IP-less. Okay, the solution in the draft is described is describing one SPE, but the operation of the SPE are quite generic, and you can have a different deployment scenario. One deployment scenario can be when both TPs are not capable to support the control word. Then what you can do, you can insert 2 types of SPE, like this one, that the SP1 will insert the control word to the packets generated by TP1, and the SP2 will do the same for TP2. And then you make sure that the traffic through the network goes through between SP1 and SP2 as the control word. Or you can have a more complex scenario where you can have regular SPE in between the TP and the SP that translate the control word. For example, if you have multiple networks where you are sure that there is no ECMP, and if you don't support the control word insertion, you can also put your insertion of the control word a little bit further up in the network. It's just deployment decisions. The behavior of the node is exactly the same as described in the draft. So it's just to show that we are not constraining the way the solution can be deployed. So a bit of history. We got this draft presented at the last IETF meeting. We get a slot in the MPLS working group, and we get good comments from Himanshu and Jeff, and we are trying to address these comments in this draft, in this version. We are trying to make it more clear that the solution is for existing deployments where we have something already in the field, and we have all boxes which are not capable to insert a control word, and we still want to protect the traffic from the wrong ECMP behavior, because this is becoming an emerging issue. Another important point is that we are not going to change other P or P nodes. So the changes that we are proposing are limited in terms of how many nodes you have to upgrade. And we got a question about the sequence number. Looking at the draft solution, in the old version we didn't discuss. In the new version we discuss, and we see that if people want to implement a sequence number, they may use it, and they can use the RFC 4448. Of course, you will use sequence number between the nodes that insert and remove the control word. Okay, what is the next steps? Okay, first of all is to validate what are the assumptions that we have. So important to understand how many devices do we have in the network which are not capable to insert the control word. And this back to the question of Stuart. Is there a problem that we need to solve? And whether they can support CC type and CV type and reconfigure TTL, which is in line with the RFC 6073. We are, of course, welcome further comments and suggestions, like how to model it from an architectural perspective. And okay, we think the document was ready for working group adoption, but let's see.
That's not what you told me when you asked for the slot.
Yes.
You said you wanted to socialize it.
Socialize, yes.
Okay, so not working group adoption.
Okay, okay.
Well, working group adoption is a good starting point, right? That's all it says.
But when he asked for the objective for the slot was to socialize this.
Okay.
Not to go.
Okay.
Well,
That's
working group adoption is always figured out on the list anyway. But Matthew has more comments.
Yeah, sorry, just a smaller comment first of all. There's a statement in the draft that this works with dynamic multi-segment pseudowires. I would only if that SPE is actually a terminating P for the multi-segment pseudowire would this work, because the whole point of a multi-segment pseudowire is you don't have to configure anything on the SPEs. They're auto-discovered through BGP or auto-advertised. You'll need to effectively configure an address on the SPEs, like a prefix for that SPE. You shouldn't have, but here you have to configure the fact that for a given pseudowire you have to do this extra function.
So you don't have enough property.
Yeah, so you'd have to have another BGP where they've advertised that property in BGP saying it's capable of doing it and that your far end is.
So I guess the critical question is there a need to do this? How much of this is do we need to do?
Yeah, I mean, I think, like, I don't have a good idea of how many of those TPs are around that really don't in hardware support control word. Especially since you're saying, well, deploy an SPE one hop away that has this new function in it. When actually pretty much all nodes out there also support configurable hashing. You could just hash on the label stack rather than going into the IP, all the way into the payload. And again, you won't get ECMP on that last hop if you do that, because it'll just hash on the pseudowire label.
Well,
Something I discussed with him, instead of putting a control word, might as well do ELIL or the fact and have those
well, if I may, we know from the experience that's being encountered in the field that there are at least some networks that are running without the control word, right? Because and there's bad hashing going on for ECMP, which is why people are seeing Ethernet frames being delivered out of order, which is why we did the Ethernet control word draft in the first place. So I think it is evident that there is a problem out there. There are still implementations that are running without the control word, right? So, we have actual proof of that.
But are those cases where you're getting undesired ECMP on the pseudo-wire or reordering of packets on the pseudo-wire? Are they really because only the TPEs don't support control word, or is it because the whole network doesn't support control word?
I believe from the experience that we've seen that the whole network is not using the control word.
Right. So that's not really, yeah, but is that because the TPEs don't support it in hardware, or is that because nothing in the network does? Because usually the network would all be deployed together and.
Right. That I don't know.
Actually, there's a higher level question. You keep saying they don't use the control word. So there's a third option, which is that they have the capability, they just don't turn it on.
Yeah, well, that's what the previous draft addressed.
Yes.
Right.
That was it.
Yeah. And if you recall, when we did the previous draft, there was objection to making it mandatory. But because some equipment couldn't do it.
Yes.
The question is, does this address that set of equipment, or actually is that equipment so deeply embedded in the network not being involved?
Throw it down the stairs.
You said which chip are there any hardware?
I don't know, strangely, you're the person who was most vociferous in saying that we couldn't make it mandatory.
Yes, I know, but we.
Well, it is not to personalize it, right?
No, I know.
That's the word that would be on.
No, but in this specific solution, you need a chip that could do a line rate, pseudo wire level.
Yes.
Oh, yeah, we
Yeah.
think there are chips that could do that. Out there. Most things that we've got a network processor that could do this
Yeah.
operation.
Right, I mean, mostly they use merchant.
Yeah, but Imanshu, that's why my point is, you're right, but as Stuart say, you need to have programmable hardware, but only here. It's not something that is up. It's not an upgrade of the whole network. It's an upgrade of one system in the network. Can be an upgrade of an existing system, can be a new system, but it's very self-contained change that you need to do.
No, it's not, because you have to change the design of the network, because you have to deploy. Normally you would have just a ton. Multi-segment pseudo-wires are not that widely deployed, and some mobile networks and things have them and things, but they're not. In this case, you're saying, well, we have to. Normally you'd have an NSP end-to-end between TP1 and TP2.
Yeah.
So you're saying I have to basically redeploy my LSP mesh in this network with an SP there and provision this switching function or stitching function of these SPEs. So it's quite a significant redesign of the network.
Of the operation, yes.
Hang on a second, but normally they would go through a concentration point one hop away from the edge anyway.
Yeah.
You still have to configure the tunnels.
Yeah.
Between the TP1 and SP1.
If-
Even if it's one hop, it won't push the level, the tunnel level if you're doing 10 element hop.
Yeah.
But you still have to have a tunnel.
It's only in certain kind of hub and spoke kind of architectures that you get a lot of pseudo-wire switching. It's not that. And I mean, these TPEs, I mean, what are we really talking? We're not really talking about CPU type devices. We're talking about things sitting at the edge of large service provider networks that are handing off, providing transport for some other service provider. So there's not a vast number of them. They're usually fairly powerful boxes, and they do get upgraded, and they, because just because they've been
SPE1, but TPE1 is likely to be a cheap box at the edge, isn't it?
well, it could be, but what do you mean edge? Is peering point with another? I mean, I'm saying it may be a peering point with another provider, or it may be for Ethernet transport. Quite often, that's what you have. It's not necessarily, or it's not necessarily a small CPU. It's not running CPU, pseudo-wires necessarily out to the premises.
Well, if it is a peering point, maybe it's, and I think this one is most likely the small one. Because if it's a peering point, is a big system, maybe have more flexibility. It could be able to insert the control word. I think the problem is when you have a chip box that is a small chip box that is deployed widespread on the edge of your network, which is very expensive to upgrade.
Right, like a cell tower or something.
Yeah,
You might have done,
right.
Yeah.
But
Cell site now.
keep
So-
in mind that what's being labeled here as TPE1 is actually just a relabeling of what was a cheap PE that didn't support the control word.
Yep.
And the only reason we're calling it TPE1 is not because it's a big TPE, it's just because it's a TPE in the architecture of multi-segment pseudowire.
Yep.
Right? But it's still really a cheap PE that doesn't support the control word.
The question is, are there sufficient out there that we need to worry about?
What I'm hearing is there needs to be more analysis on the actual usefulness of this and how many, how widespread is this problem? I mean, if we're talking about cell site routers that are going to get updated from like 3G, 4G to 5G anyway, maybe this isn't something to solve. I don't know of any other TPEs that are that small that would not get upgraded. I mean, if you're thinking about like Ethernet service,
Think TPE, not TPE.
but you just said that the TPE was a cheap box. A PE is not a small cheap box. If it's Ethernet service, it's a larger PE, right? In the case of a cell site router, you're pretty much going to rev it when you rev the base station, which is what we're going through right now. So is there another use case that would demonstrate that this thing is going to stick around forever?
Well, hang on a second. The 3G or 4G stuff's going to stay around for a while.
The 4G, the LTE stuff will stick around for a while. I'd make assertions that the 3G stuff is already being turned over. And when you do that, I mean, in some cases, the box is actually built into the base station.
Yeah.
So it's going to get turned over as a matter of course. Is there another use case though? Is there some IoT thing?
Only 4G.
What? I'm sorry, Uma?
3G is not the pseudowire, it's an IP stuff.
Well, no, it's all ATM, but then we're not talking about Ethernet. But I think Stuart was referring to like the HSP.
Now, I have a question for Himanshu. Himanshu, previously you've argued that there's old equipment out there that's hard to upgrade. And what's the particular use case that you have in mind when you make that argument?
We should probably be doing it. I'm not sure because everybody.
I am not recalling the discussion.
Well, for example, when we had the discussion on the control word draft, you made the point that that we can't just mandate that everyone upgrade to use the control word because there's equipment out there that can't be upgraded, right?
Yes.
And so I'm wondering, just what's the use case that you had in mind in terms of that equipment that can't be upgraded to use the control word?
So, from my experience purposes,
Yes, exactly.
we have deployed a lot of mobile wireless backhauls,
Mhm.
and they are all using MPLS TP. So we use CC Type 4. So we don't have this issue at all as far as the control word and all those things are concerned. I think one of the, if you have boxes, small cell site like Matthew, and it is true for mobile wireless backhaul. At the cell site, you have cheap access boxes, which doesn't have a lot of CPU and the memory and all that stuff. They may, if that hardware does not support the control word, you can't upgrade them to. You just have to swap out the box, which supports the control word.
So
This will give you that avenue. Ooh, wow.
So Stuart, so that would address that situation. The question we need to ask is that situation likely to resolve itself due to a 5G upgrade sufficiently soon that we don't need to worry about it? Or is that problem likely to continue, in which case elements of this would be useful work?
So again, from my experience perspective, I said, we have large deployed networks for mobile wireless backhaul, but we use the MPLS TP. We don't have this issue of control word. Now, when
But
this box is
because
back-
MPLS-TP doesn't have ECMP, that's why you don't have this issue.
sorry,
You mentioned that you don't have this issue because of MPLS-TP. That's because MPLS-TP is not using ECMP.
no MPLS. We are using
Okay.
GalGatch, right?
Okay.
We use the CC. So there is no intermediate boxes that looks beyond the
Okay.
last label
Okay.
and
Okay.
yeah.
There is no ECMP in MPLS-TP.
Yeah,
I
yeah.
see. Yeah.
So-
So you don't have this problem.
We
Yeah.
don't have this problem
Yeah.
in our networks. But to stewards, if we are upgrading to 5G, there will be newer boxes, of
Yeah.
course, and then which would have this control word capability. I mean, our newer boxes all support control word.
Just to clarify one thing, Stuart, again, I thought MPLS-TP required the control word.
GalGatch.
Yes.
Yeah.
Right. So
So
we don't have a problem in any MPLS-TP network.
Exactly.
For two reasons. It doesn't ECMP on you, and it always has the control word.
That's my point. Yeah,
Okay.
that's precisely what I was saying. Is that in our deployed networks we do not have this problem because we are using GalGatch.
So
I'm not
No, I'm
even, sorry,
confused.
not even sure in these networks is that you get a whole lot of true multipath ECMP. It's all like link bundling. And in that, if you really want to control the way that you do spraying across the links, you hash on the pseudo label. You're not just going all the way into the packet. So this is not going to solve a problem really there, because you do want to do hashing across the links in the bundle. But you configure the network so that it hashes correctly.
I think this Ignas, right? Ignas was the one who actually put this problem on the table that he's seeing a lot of networks where the out of sequence packets are happening and then we got a letter from IEEE that if you don't fix this problem, we're not going to assign the MAC address
Right,
starts
the
with
rack,
04.
Right, but those
rack
networks are not this.
No, the networks, if I'm not mistaken, the examples that they were giving were more like enterprise Ethernet services and like data center interconnect, not places where you have cheap, dumb GPEs that you don't want to throw away.
Yeah,
And then you need to
those kind
solve
of
it.
examples were not, the boxes can't possibly be upgraded to use the control word. They were just the software doesn't support control word in
So,
certain situations.
yeah, so I mean, I think at this point, I don't know, what I'm hearing is that there does need to be some more analysis on exactly what is the use cases for this, and is it likely that we would need to do an augmentation of the protocol to handle, and even the architecture to handle this, or are there other solutions that already fall within the architecture that will get us through?
I mean,
So we can just
So
take
if we
it
don't
forward.
change the
Well,
architecture
yeah, the
and if
question-
you just do the two pseudo wires, but then you don't have the native
right.
VCCV
then
OAM,
a lot of this complexity disappears.
and not all this complexity disappears. Yeah, but then yes, you have pseudo wire termination at the midpoint, but it facilitates the original goal is that if you have a network with which is looking below the pseudo wire for the ECMP traffic, you will solve that problem.
Yes. So the question is, my view is how many of this TP do we really have in the network which cannot be upgraded? Because I think that
In what cases too, yeah. I mean,
Yeah.
what are the, like Matthew was getting at,
Yeah.
so you may have a lot of them that can't get upgraded, but then, I mean, are you also in a situation where you're consolidating them back to a single point?
Yeah.
Because even if you're not,
Mhm.
right, then you don't really have a choice. You have to go upgrade them anyway. Because the topology is not gonna, if the topology isn't more hub and spoke like, you're not gonna have a situation where you can upgrade one node and get away with it.
Mhm.
Right? So you kind of need to look at both things. Like where, because I mean, it's not just the TPE can't be upgraded. Usually it's a case of I don't want to upgrade that
Yeah.
because there's so many of them. But then again, is the topology such that I have a central point to bring them all
Where I
back?
can
Converge.
deploy this new network. I see. Okay.
So, this is Stuart, I think probably the right thing to do is that the authors should write a summary of the discussion that happened here, put it to the list, and ask which essentially of two approaches we should adopt, which is to continue this piece of work or simply write a short note, which may or may not be an RFC, that says if you build a pair of stitched pseudo wires, then you can address this problem. But you can't solve the OAM, end-to-end OAM.
Yeah.
And,
Yeah.
get the working group and then decide what it wants to do.
Yeah, Stuart, just a question. Without VCV, also you have to think about how do you move the traffic away. Maybe it's, again, because you have the traffic is already going through this old pseudo wire, and if you do a multi-SEM pseudo wire here, you can do pseudo wire redundancy.
With stitching, you don't get those properties, but we should describe the properties of this, the properties of the alternate on a list, or maybe a draft if it's more than a page, and then ask the working group which way it wants to go.
Mm-hmm. Okay.
Yeah.
Also the pseudo wire status signaling, if we were to do the two pseudo wires.
I think that pseudo wire status signaling you can move forward, because I think there is some forward. You can take some pseudo wire status from here and move it from here if you stitch as a native service. If I remember well, this is possible.
There is that OAM interworking.
Yes,
but
exactly.
That's for the Ethernet native.
Yeah.
Whether
But to be honest, I think quite often with these small cheap TPEs that you've got here, you quite often don't have dual homing from them anyway. You might have link aggregation going.
No.
That's not link, but that's it.
Yeah, so let me add on to that, because in the architectures that we've done, for example, in the broadband forum where we utilize this stuff, the idea was that you didn't do dual homing from a cell site gateway, because if it died, the two adjacent cells are going to pick up anyway, and they didn't need to add the cost into the box.
Yes.
Right.
The backhaul cost is too high here.
The backhaul cost was too high. In some cases too, where you'd have dual homing, say it was a macro site aggregator. Well, all right, then you would dual home to two PEs, but that's not going to solve this problem. Right? That you're going to need two of these SPEs to solve that problem.
Yeah.
It's cheaper. In other words, it's cheaper to update the cell site gateway to support the control word, right, than it is to put two SPEs in that support the control word.
We're gonna have to end it here because Italo was actually up on the T's agenda soon. So Italo has to rush over to T's. But one thing I would like to add is that there was a question as to whether we should hold the session or just put this draft on the MPLS agenda. But I think it really got the attention it deserves from the right people in the room by holding the meeting. So I'm really glad that we did. And we'll continue this online, and depending on the way the discussion goes on the list, we'll see whether or not we need a meeting at the next IETF.
Thank you.
Okay, thank you all.
Yeah.
I'm coming.
I have a question for you.
Is that over by the chair?
When can I have? Okay. Yeah. Yep.
It wasn't my bottle, but I must have got shoved off.
I don't know, worry about it.
You didn't fall down, so it really is.
So I think it's a useful discussion. as it turns out.
The
Absolutely.
discussion was, I hope I captured as much as I could. So that summary that you were just talking about, having the authors do, hopefully they can pull a good amount of this.
Okay.
You know what? I'll clean these up before I upload it.
If
I'll
you
try
do it
to
as a
listen.
summary, if you do it as a summary, it might make sense to do it as an RFC that updates.
For like an applicability draft.
Yeah, so it's a question I had.
Well, that'd be a good question. You can do it
Can I have
building draft.
dinner with you now?
Update to
Oh,
RFC on-
That's a good question.
Could do, yeah.
Because right now I think we're wide open.
Good. I'm wide open too.
Okay, so let me see.
Planning, I think, is Wednesday.